We're talking about creating evolutionary design and architecture. Let's continue with our discussion. We talked about quite a number of ways that we can make our design and architecture evolutionary. We're talking about parsimony right here. Parsimony is minimalism. Do the minimum you can and postpone things you don't need right now and try to really minimize and keep everything you do as small as you possibly can get away with. Well, this is one of the biggest problems in today's world is that we got a lot of things available for us free. Back decades ago, you had to purchase libraries. So your decisions to use libraries were limited because of financial concerns. Even today, there are certain organizations where you cannot just use any library. There are governmental regulations, for example, or other things. But for a wide variety of organizations, you can pretty much jump around and use things that are available. And I like this freedom to have opportunity to use things that are available. But that has one significant negative impact. And that is we tend to really pollute our application with a great amount of dependency than we really need. And this is something we really need to be extremely careful about. So parsimony is where we really try to build with the most minimum things you can get away with, and at every angle, do I need these many classes? Do I need to depend on this external library? Can I do without it? And I'll talk about a few things that can be very beneficial to consider. First, the more libraries and frameworks you depend on, that provides you efficiency, but it comes with an enormous cost. You got to keep your application maintainable, and as these libraries evolve, you got to evolve your application with it. So if a library you depend on is evolving rapidly, or they implement a few bug fixes, they break compatibility, you got to go back and fix your application to stay in tune with it. If you don't, you're increasing your technical debt. I came across a team recently and they told me, literally, no kidding, they told me they are using 150 JavaScript libraries. And I looked at into the eyes of the developer and I asked him, honestly tell me, do you think your application needs 150 JavaScript libraries? He laughed and said, no, it doesn't. Now, why did you use 150 Java libraries? He said, because our developers said, oh, for this I could use that library, for this I could use that library. And very quickly you get drawn into these libraries. What's the consequence? They had automated tests, use the word past tense, they had automated tests. They're not running their automated tests anymore because those automated tests don't work anymore once they started upgrading some of these libraries and nobody had time to go fix all of them. So ask yourselves, do I use a library or not? Now, I'm not going to tell you don't use libraries. That would be silly to recommend it. But I'm going to say minimize the libraries and frameworks you depend on as much as you can. Before I pick a library, I think several times over. I use libraries very reluctantly. I have applications in production, and you may say, do you use libraries? Of course I do. I use jQuery, for example. For JavaScript libraries, I quite often do that. But do I simply go out and bring libraries because they are there? What about Ruby and Rails? Do I just go download gems? Do I have gems in my Rails project? Of course I do. What about my Java projects? Do I have JavaScript, Java libraries for XML parsing? Of course I do. However, I bring them very, very reluctantly. I'll give you one example of this that I did just recently. I was working on a Rails project and I wanted to implement one certain feature. And the first Google tells me there are 3 gems available to implement that feature. And the 3 gems available, I can simply do one-liner gem and bring in gem install. And once I do, I just have to put 1 or 2 lines of code and bam, it's done. What a great idea, right? So 5 minutes later, I can have this feature working. But something told me, wait, do you really need to bring in this gem for this particular feature? Well, sure, Venkat, you can have this running in 10 minutes. Why would you not? Then I looked a little bit deeper. Some of those gems are no longer being maintained. Some gems are relatively new. Some other gems have been around for quite a while. But it really made me think, I want this feature but the cost of you implementing it is 10 minutes now if I bring in this particular gem. And don't get me wrong, I do use gems. But if I bring this gem, it's going to take me 10 minutes to bring this in. But what's going to happen in 3 months? What's going to happen in 6 months? What's going to happen in a year? What's going to happen when I start upgrading Rails? What if I upgrade Rails and this gem is no longer compatible with it? What do I do? Well, the point is, the cost of writing this is 10 minutes now, but the cost of maintaining it is quite unknown. And then I thought to myself, if I were to implement this myself, how much time and effort would I need? And I thought about this a little bit. At the onset, it looked like frightening. Oh my gosh, that's a lot of complexity to implement it. Then I started thinking about it. Well, if I'm not going to use a gem, how would I approach implementing it? And I quickly realized it only is going to take me about an hour to really implement it with automated tests. And I spent the hour, implemented it just in one area of the application I was working on. That's all I did. 3 days later, I came to another area of the application where I needed the same feature. I triangulated that into a base and I reused it in 2 places. So it took me another 10 minutes to 15 minutes to get that moving, to make sure that it's all refactored properly. And that was the cost. And a few days later, I needed that in another area, but this time I have already abstracted it, and so reused it quite easily. And so as a result, with an hour of implementation, a few minutes of refactoring it, and making sure everything is working fine and integrated, all is the effort it took me, but that is really a native code I wrote for that feature. I could be upgrading to versions of Rails in the future, but I don't have to touch that piece of code anymore because it doesn't have any external dependencies. And so the point really is, when I bring in libraries, I don't bring in libraries because I can use libraries. I bring in libraries because it would make me a lot more productive than implementing it myself. So I tend to really minimize the use of libraries and only bring in libraries when I feel that my effort to implement it outweighs than the effort in using it on my project. And so, for example, I would definitely not consider writing my own database, of course, right? So clearly, I would reuse a database. I would not. Don't get me wrong, but I've come across clients who have their own proprietary databases. I was talking to a client recently, and they said, I asked them, what database do you use? And they told me the name of the database. I said, surprising. I've never heard about that database. So with a big smile, they said, yep, that's our own proprietary database. I said, wait, you mean you guys wrote your own database management system? Like, yep, we did. I said, really? And how many people are maintaining this database management system that you guys wrote? Oh, we got 40 developers doing it. I said, how's it going for you? Not very well. So the point is, why do you want to create your own database management system? You definitely want to use something that's available, open source or commercial. Likewise, I wouldn't create my own frameworks when I can use another framework, but only if I need it. But having said that, when it comes to picking libraries, be extremely reluctant in picking libraries. I came across this once where I had a developer come and tell me he's going to use a certain library. And I asked him what his project is, and he tells me what the project is. And I said, I really don't understand why you need this library for this project. He immediately said, Venkat, do me a favor. Please don't come to talk to my team or to my boss, because we convinced everybody we need this, and we don't want you to come and mess it up. Well, this is called RDD. It stands for Resume-Driven Development. We bring in and use stuff because it looks good on our resume. So avoid the temptation. Do not pick technology. Don't be infatuated. So infatuation is very, very difficult thing to avoid. Don't be infatuated to technology. Use libraries and framework only if you absolutely need them. Apply YAGNI. Apply the last responsible moment in bringing them. And if you need a library, ask yourselves, what's the cost of you developing it, and what's the cost of using that library in the future and maintaining it? And if your cost of development outweighs the cost of using it, and if you really need it, only then use the library, not otherwise. Now, I'll give you an example of this, which is a very heartbroken example. I was working in a company as a consultant, and this was during the hardest of time when the economy was really down and people really had trouble finding jobs. And I was working in this job, and we were developing this application, really exciting application for a very small company. And the company decided that they wanted to hire more people, so we started interviewing people to hire, and we came across some candidates, but one candidate stood out. This candidate has developed a framework, and very fantastic framework. So we interviewed this candidate, we really liked him a lot, and so the hiring authority in the company came to me and said, what do you think of this candidate? I said, don't waste your time talking to me. Go make him an offer right now, hire him, bring him on board. I think I'm going to have a really great time working with him. He is absolutely phenomenal, knows a lot of stuff. I'm really eager to work with him and learn from him. He said, what do you think of the framework he's developing? I said, that's a phenomenal framework. I've never seen anything like that. I love it. And the next question he had was, what do you think of us using this framework in our application? I said, wait, don't even go there. Our application doesn't need it. Don't talk about the framework. Don't commit to anything. Hire him for his technology, hire him for his knowledge, hire him for his experience. Put him to work on this project. Let's focus and deliver this application. And a few weeks went by, and I reminded them, don't use the framework, just hire the person. And about a few weeks later, I was sitting and coding away at my desk. The hiring authority walks over, sits on my table and says, well, I got a news for you, Venkat. We have extended an offer and he has accepted. I said, I'm so thrilled. Absolutely. I can't wait for him to start. It's going to be a really fun learning experience, and we're going to really create this product. It's going to be great. He said, well, as part of the hiring decision, we have committed to using his framework. I leaned back in my chair, thought about it for a second. I said, I'm really sorry. This is a bad idea. I quit. He said, that's so predictable. I already told the organization that this is what is going to happen. I said, look, what you need right now is somebody who will run with you. You don't want somebody who is a stumbling block. I think this is a bad idea, so it's better that I get out of this, and good luck. And how long are you going to take to finish this? Oh, we're going to be still on schedule, 6 months, we're going to release it. I said, good luck, and please do call me if I can work with you on any other project, but I don't want anything to do with this project. And I left. Well, 18 months later, not 6 months later, but 18 months later, my phone rings. I say, hello? He says, all right, go ahead and say. I said, go ahead and say what? Well, I told you so. But I'm really sorry, what happened? Well, in the 18-month period, what they were supposed to finish in 6 months, they had built so much code, and every time they went around to use this particular framework. Why did they use the framework? Well, the hiring authority was a technical person said, oh, did you realize that he talked about this wonderful distributed messaging? I said, we never talked about distributed messaging so far. Oh, Venkat, you don't have a vision. We should use a distributed messaging. Well, yes, you can, but let's release the product. Then let's talk about how distributed messaging is needed. Did you see the absolute fault-tolerant persistence layer he had? Well, we never talked about fault-tolerant persistence right until now. But imagine what we could do with it. Well, let's deploy the application in 6 months. Then let's talk about fault-tolerant persistence if that's important to you. Oh, no. There was infatuation to this technology. And so every time they started using this framework, it did almost what they would like it to do, but not quite. And in the 18 months, they had built more code to maintain the framework than to build the application. And he's called to say, would you come and help us? I said, no, I'm sorry. Had I been a lot younger, I would have said yes, but I'm to a point where I want to work on things that succeed. There's a reason I quit that day when the economy was really poor and I went jobless for a few days before I could find another contract. But the reason is I believed that this is a bad idea and I don't think I want to be part of it. So the point really is, don't be infatuated with technology. It's very important to pick things for the right reason. If a library is really something you really need, don't look at the library and look at the feature list and say, how can I use any of these? Instead, come up with what your application needs are first and make sure those needs are real. Then look for libraries that solve your problem rather than trying to find problems you can solve with the solutions that's in front of you. So minimize the libraries that you would depend on. Paulson's law is another way we can develop architecture that's extensible. Paulson's law says that when you are interacting with systems, be very conservative in what you send out and be very flexible in what you receive. For example, let's relate to this at the code level, then we will relate to this at the application integration level. Let's say I'm creating a class, and in my class my class contains let's say a method. So it's going to say receive, and I'm going to say I'm going to receive an array list of something, let's say foo. Well, let's say values. So what am I receiving? I'm receiving an array list of foo, which means the sender can only send me objects of foo in this array list. Well, that's fairly limiting. I could instead say receive to, I could say a list. A list is more general than an array list, which means that the sender could send an array list, but the sender could be sending some other implementation of list as well. I could also say, give me a foo interface, for example, rather than foo, which means they could give me an instance of foo in it, but it could be something else as well. For example, let's say we could say, in this case, a media. Well, if I say media rather than CD, for example, as an example, rather than saying I'll only receive a CD, I'm going to receive a media, which means you could give me something in different forms, or rather than saying an array list, I could get a list. Likewise, when you are designing subsystems, try to be as general as possible in what you receive. Don't try to be very specific about what you receive. Be generous about it. If I'm going to receive a data of, let's say, an inventory, don't try to validate against every single field in the inventory. You say, you know what, give me inventory details. All I care about is these 4 fields. As long as those fields are present and are in the valid format, I'm going to be very relaxed about what's around it. If you do a complete validation of the input, the minute they change the data format, which doesn't affect the area that you care about, you no longer can receive that, and we got to go through a change. But if you are only picky about the part you care about, and very relaxed about the parts you don't care about, then if they make changes to the parts that you don't care about, it doesn't affect you, you can still receive the data. So when it comes to communicating across boundaries, be relaxed about what you get, but be very specific about what you send. So when you send the data, don't send verbose amount of data. Try to be minimalistic and send only what's relevant. If some data is not relevant, don't bother sending it. So when you, in the code level example, if you're going to be calling a method, some method you're going to call, maybe another function you have here, some function, and you're going to call, so you could say instance, some other instance dot, and you're going to say send, and you're going to send some data to that particular instance. And what are you going to send? Be very specific, like an integer. Don't try to make it generic at this point. Be very specific. Or if it is an object of some type, whatever that type is, create an object of that type, maybe a string that you're creating, right? Or maybe an object of person that you're sending. But be very concrete in what you send, but be very generic in what you receive. So in other words, this is at the code level, but also at the system level. So don't be rigorous in your validation, be relaxed, and only look for things you care about. And when you send, don't be too verbose, only send what is really important. And that can help us really make the code system extensible, because you're not making things brittle by being so concrete, and you are able to make it extensible because you give the flexibility to vary things. One other thing is testability. When you design an architect for testability, you design an architect very differently than when you don't consider testability. And so create with testability in mind. When you architect for testability, your components and classes become more modular. They become smaller and more cohesive, and they also end up being decoupled. And I'll talk about testability in another light. I was developing an application not too long ago, and I have about 12 different languages and several libraries and framework I can choose from. And I had this freedom to choose, so I decided to implement it. A few months after I went into production, somebody who is representative in the industry about a certain language, I was just having a lunch, and he asked me what language I chose to. And he was not very happy when I said I had went with another language. And he said, well, I'm really not happy that you didn't choose this particular language that I am really involved in. And I said, maybe you should ask me why I chose the other language and not the one that you're working with, even though what you're working with is something I really, really like a lot and I promote it. The reason for that is testability. I was able to test this so very well in an automated manner, and testability was the number one decision I went with this particular framework, and that makes a big difference for me. So that is something to think about in terms of testability, if you will. And another thing to think about is Conway's law. If you can read about it, Conway's law says usually the architectural architectural structure of an application corresponds to organizational structure. So it normally says that if a company is organized in a certain way, then the product layers fit into those tiers as well. I once worked with a company where they had 8 teams across 10 different countries. And guess what? Their product had these 8 different particular layers in it. It was a nightmare to make any change to this application, because if you had to introduce a change, you had to talk to these different teams to make that change. And it took several months to make even the smallest of change. So if you really want to change your architecture, you should really change your organization. So there's a saying, either change your organization or change your architecture, because they go hand in hand by Conway's law. And the last thing I will tell you is integrate early and integrate often. This is one of the biggest problems in what we involve normally in development, is we do integration very late in the game. Modern Color has a wonderful article blog that says, if it hurts, do it often. I've seen this quite a bit. If we do integration very infrequently, it becomes really painful to integrate. If we integrate quite often, if we do continuous integration, it becomes relatively easy to integrate. For example, I was in a project where they were working on a second version of the product, and when I joined the project, within about 2 days I figured out that the developers were focused on just the second version features. And I came to know they have completely discarded the previous version, and they're going to do a big bang integration in the end. And I was very nervous about this. I asked them, what about integration? They said, don't worry about it, we'll work on it later, we don't have time for it. And I asked them permission, if you don't mind, can I play with the old version and just try out one integration example? They said, yeah, you can go ahead and try that. And I spent the evening trying that, and I found out that if you have to integrate your components to the existing version, you have to do it very differently than what they had been developing so far. And once I found this, I called one of the lead developers and said, here's the code, and if I have to integrate this code, here are the changes I have to make. Can you imagine making all these changes in the end? And the minute he realized that this is the complexity involved, we stopped development right then and spent the next several days converting all the code to the newer format we needed, integrated it, and moved on integrating the code every single day. Integration is an extreme risk, so integrate early and integrate often, and make sure that you do not postpone integration to a later time. And evolution becomes extremely difficult if we do integration very infrequently. So we talked about quite a number of ways we can improve this, and there are things we can do to make evolutionary really, really easy, but it doesn't come without effort. Like I said earlier, we have to create evolutionary design. There's a risk for not creating it. There's a risk of creating it, and we can address them in several ways. Evolution should be deliberate. We can do a number of things we talked about to make our design and architecture evolutionary. But it is something that the team has to collaborate and develop, and a feedback loop has to be established. And so if you're evolving the application, evolving the architecture, make sure you attack the hardest problem first. Make sure you do in vertical slices. Make sure you have automation testing. Make sure that you postpone things you don't have to work on right now and try to keep things minimum. Apply parsimony. Don't be infatuated with technology. Only use the minimum set of things you can do. And also try to keep the code clean and maintainable and readable as well. And so we can create evolutionary design and architecture. It's possible to do it, but it doesn't come for free. We have to put in effort, deliberately do that.